So welcome to Axon-powered microservices at the Dutch police. This was a talk we kind of came up with an invitation. I had a lunch meeting one time with Jeroen, and he came to ask me two things. He said, one, are you using Axon Server? Because we really want you to use Axon Server. And two, can you tell us something about what you're doing with Axon? Well, answer one was no, we are not using Axon Server. And two, yeah, sure, I'll talk about what we're doing. So let's just get right into that. What are we doing? We are trying to... oh, wait, that's one too far. Thank you, Clicker. What are we doing? We're building an event source system that hopes to digitize the criminal justice chain. And to give you a little bit of perspective, within the digital, within the not digital justice chain right now, there's a yearly production of about 3.6 kilometers of ordners filled with papers that end up in some archive somewhere in a large bunker. So that's a lot of paper for 1 year, and the system we're trying to build is trying to replace all of that paper by simply one large cloud-based application. That's number 4. It's a cloud. Well, obviously it's a private cloud because information is generally highly classified. But we're building it in this new modern way to just be sure to scale for the entire justice chain as one single user instead of just making 3 different parts for three different parts of the system. As part of the initiative, we're using just open source. So that was one of the answers why we said we're not using Axon Server, because their first version of Axon Server was paid only. And we said, well, paid only, then we can't use it. But since there's a community edition, it's high on our list to look into because it might actually solve some of our problems. And well, the third term is one you probably see a lot these times when people introduce what they're doing. Cloud native services, everyone's doing it. We're doing it. And we can do it because we have our private cloud, which we control. We actually control the hardware all the way up to the software. So we can switch technologies whenever we want. So that's basically what we're doing. It's a very challenging project because it's got this very large future user base, very large data requirements. Actually there's some good reasons why we chose to use Axon for this. First of all, you heard Joris tell it, why most of the companies choose something like Axon is auditability. The entire justice system demands that every action that has something to do with the judicial way in court has to be able to put back to who did it, when, and maybe even why. So that if in court somebody asks, hey, why was this picture uploaded and where did it come from? Somebody's going to ask it to the system. If the system can't answer it, we at least have to still be able to answer it from the data. And event sourcing is just a perfect match for that because we simply store every action as an event. But I'm sure you all know that, otherwise you probably wouldn't be here. One of the other things is we're not just building it as an agile team and trying to do all of those things. We're also trying to implement it in an agile way. That means we've selected a small group of users to start using the system. Like what the keynote this morning said, our purpose is to make this small group very, very happy. If the small group's happy, we'll add people to the group, we'll add departments to the group, and that will slowly increase the requirements for the system. And Axon is very, Axon just event sourcing and CQRS in general is very well fitted for that strategy. Because if over time somebody says, well, you now have to connect to this archive system, for example, that has a certain API and requires information to be stored in a different format, we'll say, okay, that's fine. We have our huge event stream with all of the information of what happened ever. If you want it in this format, we'll just create a projection, a read model specifically for you. And that also fits within our microservices approach as well. because we can then just build a dedicated microservices with a dedicated model and a dedicated projection. And it gets its own life cycle, and we're not tied down by it by the rest of the application. So all of that made us choose Axon. We chose it about 2 years ago. We started this project, and I'm happy to say we'll be going into production next month. Well, it's a project at the government. It's new, and it's going in production after 2 years of development. There's usually, at least in the government, people say that's impossible. Well, it's possible because we're staying small and we're growing it slowly. And we use Axon. So then there's the other question: why are we using Scala? Axon's built on Java. It's tightly coupled to things like Spring. If you want to start it up and you're using Spring Boot, it's easy. But as soon as you deviate from that, things get hard. So why did we do this? Well, let me first get the question: is there anyone else in this room that's not using Java with Axon? 1, 2, 3, 4, 5. Can I see a hand for Kotlin? Anything other than Java, Kotlin, or Scala? Nope. Okay, that kind of fits what I expected. Well, the thing is, our team of developers was pretty strong in functional programming. We'd been working together as a team before with things like we worked on Scala. We built a DSL to perform calculations, and so we were really fluent in Scala and building systems with it. Additionally, we had experience from building an Axon system, except it was in Java back then, but we really wanted to use Scala because it's neater, and at least it was, it still is. But and another thing that Scala really supports, or it fits a little bit with event sourcing, is that in Scala you have the notion of case classes which are immutable. And I mean, Kotlin has the same concept. They also have immutable types, and Java does not. So when you're building a system that's based on part of its data being immutable, it feels kind of iffy if the data is actually immutable. So we like the match between immutable events and also immutable structures in our language. And well, if you've ever tried configuring Axon manually, you will probably have noticed that since Java 8, Axon really likes functional programming. Axon's API is filled with these single argument method interfaces, and they're later been replaced by the notion of lambdas. So the entire configuration consists of lambdas. You basically, when you configure, you say, oh, I want to create something when the configuration is up for it. So here's a generator function, here's another generator function. And that matches really good with Scala, because Scala has functions as first-class citizens since its introduction. So that's just a really good fit. Then to get to the part what made us choose both, we were looking into this at the start of the project, and we were looking at, have people done this before? Do they like it, or do they dislike it? Well, don't go back. The problem with this was there was very, very little experience with using Scala and Axon together. There was this library called Synapse. We were very hopeful about it, saying, "Oh, cool! There's something that looks like a Scala binary specifically for Axon. It's in the Axon Framework GitHub account, so it must be something officially supported." But when we started, we noticed the repository had no commits for a year, and it was lagging 3 or 4 releases of Axon. So that was like, is this a good idea? Yeah, probably not. So we decided just skip it. Okay, so if there's no Synapse, then what kind of things are we going to run into if we're going to try and to do Scala and Axon together? Well, turns out you'll run in quite a few things, and this talk is about showing you a few of these things Yesterday we had the Axon Advisory Committee meeting where I had the happy surprise that I was not the only one using Scala and Axon together. There were two of us. And the fun thing is when we got talking, we discovered that we had solved a lot of the problems in almost the same way. So I'll give you a sort of an unofficial announcement that we decided maybe it's an idea to open a new repository to share our code in which we solved problems to work with Scala and Axon together in a modern way. So there's no slide for it because I had to give the slides to you to the organization last week. So I can't inject a nice slide saying we'll be creating the new Axon Scala module. But at least it's the intent that we discussed yesterday. So maybe more on that later. All right, the first problem came in the boot up of the framework. If you're using Java and you're using Spring Boot, then it's really easy. You have this Spring Boot starter module for Axon that does your default configuration of your database, and it discovers a lot of things for you. It scans your class path for your aggregates, your sagas, event handlers, and any command handlers you might have living outside of an aggregate. Well, fantastic. But if you decide not to use the Spring Boot module, you won't have any of this. And that's what we ran into. We are actually using Spring Boot at our department because all of the cloud interfacing is taken care of in sort of a shared parent project. So we do have Spring Boot, but we try to keep its influence on our project as small as possible. So basically what we have is it allows us to start up the application. It will give us a context, and we use the web interface to interface with the rest of the world. But beyond that, we want to switch as soon as possible to the Scala world. We don't want to have any bleed overs of more Java stuff in our Scala code than necessary. Because if there's one thing that's bad, it's mixing Java and Scala code. You can do it, but you get, especially on the Java side, you'll get all sorts of funky syntax. So we had to look at this. And because we use some of the Scala Scala libraries for things that are in the Java world handled differently, the Spring Boot modules didn't just correctly wire all the things we needed. And after trying to fix some of those, we decided, well, that just looks like we're patching up a system that's not really designed for this. We dove into the code of Axon, said how hard can this be to initialize this system, and that was back in Axon 3.4. That was really hard. We ended up extending classes like default configurer and default command bus, because a lot of the configuration in Axon 3.4 was protected or private. You could configure it if you knew exactly what you had to do, but it came down to a lot of things where we just extended the class to override just one type of component in the Axon library to do just one thing slightly differently than in the Java world. So that was horrible. It would have been terrible to put it on a slide here, but since Axon 4 has builders and we've upgraded to it, our configuration boot up is just actually this, and each of these 4 functions does exactly what its name implies. It configures those components for Axon, and I think this can be part of what we could be sharing, maybe a little easier configuration for the Scala world. But it's been reduced to this, and these functions simply list our aggregates, they list our sagas, they list our event handlers, and that's done. Okay, so I was talking about immutability, and well, there's a lot of immutability in an event source systems, but there's also a lot of mutability. And where there's a lot of mutability is inside an aggregate. One thing that's also mutable by default is its ID. And that's just something that we Scala people, fans who like immutable things cannot get our heads around. If the ID of an object is mutable, it won't stop a developer that's new in a project from accidentally overriding the identifier of the aggregate during one of the event handlers and probably messing up a lot of things. So when we started working this, we were looking into how does it work, why does it have to be mutable? Well, it has to be mutable because this part of the documentation of Axon that says, note that the aggregate identifier must be set in the @event sourcing handler of the very first event published by the aggregate. Well, the @event sourcing handler cannot be a constructor. So we couldn't get around this the normal way by saying, okay, well, we just have a constructor annotated with an event sourcing handler and it'll just set it as a val and be done with it. So this was again one of those points where you said, okay, we're at the beginning of this project. Either we're going to fix this or we're going to accept that our IDs are mutable. And we decided not to accept it. So we built our own aggregate factory. That was again diving into the framework, figuring out how it works, and learning exactly what the framework itself does with this. And our first version was, again, horrible. It was, I think, 300 lines of code just to recreate an aggregate factory and do what had to be done. But that was after a few iterations. It became so elegant it just fits on a slide. And this is what it does. It peaks at the first event of a stream, and it tries to find a constructor that matches the ID, and it's so elegant it fits on the slide. So this is our aggregate factory that allows the creation of an aggregate in Scala with an immutable identifier. So I'll put it somewhere up and at least these slides. But what it does is it tries to find one constructor with one argument that matches the aggregate identifier of the event. If it finds it, it'll invoke it and return the aggregate. If it doesn't, it'll post an error and say, I'm sorry, this aggregate is not compatible with our factory. And this is really good. I think we spent maybe 2 days on trying to get this to work. And ever since, we can forget about maybe accidentally reassigning the identifier of an aggregate. So this is something, I think this should be standard in Axon. Because that's about the only immutable thing of an aggregate. All right. There are some other things where we think Scala actually makes it easier to write code in Axon. And one of those is I dare to claim that we have smaller handler methods than in Java. This is partially because the syntax of Scala is more concise, and some of the things can be left out. But generally, when I open up an aggregate in our Scala projects, it reads easier than when I pick up a large aggregate from a Java project. And one of those things is when you're handling a command, generally what you do is you validate the state of your aggregate to see if the command that's been submitted can be executed or not. So basically what you have is you have a lot of validation going on, and then finally you're deciding to apply events or not. Our initial versions with that was a lot of ifs. If, nest, else, etc. Some functions to extract it and make sure that Sonar doesn't complain about too many nested things. And at some point we grew tired of that, and we said, we have Scala, we have 4 comprehensions, we can deal with situations like propagating 2 types of results. One that says there's a validation error, and one that says we have a successful result. And that's something that matches very nicely with the 4 comprehension, where you can, if you forget about the 4 and the underscores, especially if you don't know Scala, then you could actually let this be read by someone from the business, where you say, okay, I'll validate if something's correct. If it's correct, I'll succeed with no operation if it already exists. And if all of that falls through to the last situation, I'll succeed with a new event and be done with it. And all of our handlers now look like this. And we try to keep the syntax of the validation methods as close to the model as possible, so that our business can also read it and say, hey, why are you validating this? So if it's wrong, then tell us how it should be validated. So there are no complicated ifs anymore. The way this works is every function here returns either a success case or a validation error. And a success case can be empty. For example, the rule on top, when it says success, and it means the thing is valid, and it'll just propagate an empty value. As long as the result of every function is a valid response, it'll fall through. And the first of these things that says, okay, well, I'll have some sort of result that has to break it off, then the function stops there. And so if you look closely, then this one is a little bit of a cheat, because actually this one returns something that says, hey, validation has to stop here, but it'll still return an empty one, causing this one not to work. But this reads a lot easier than having a lot of nested ifs. And it's, as far as I know, at the moment, this is something you cannot easily do in Java. All right, time flies. Then I'll skip right into this. While we were building this system, I'm also a bit mostly responsible for the architecture of the system. So at some point we said, well, we're working in a functional language. We've built microservices. We've got a command handler producing events, and then we have certain sinks that consume these events and turn it into something else. If you look at it from high up, that sounds a lot like something functional. I have a stream of events, and the projection just sounds as if I'm mapping a set of something to something else. So if we're trying to look at that from the architectural level, then maybe we can apply easy things like that. And we're now trying to do this. A little bit of background: we made the mistake at first to create one project containing the domain model, containing shared classes, which all the tracking event processes and subscribing systems had to use. And then you had the problem which Joris just described. If there's one domain change, you have to deploy all of the applications at the same time because they have to support the same model. Well, that's something we learned quickly and got rid of. So what we're doing is we've decided to just model the events as a contract. And that's a contract between the command handler and tracking event processors and sinks, as we call them. And those that contract can evolve, but since they're not using shared classes anymore, you get the benefit, exactly what Joris said. The sinks that are reading the events can safely say, okay, this looks like a newer version of an event, and I know it maps to the old version because it has the same fields, but we can still process it. And we don't necessarily have to update the sink if its functionality can still work while ignoring those values. But it allows, this functional architecture allows you to couple this as well. We have, for example, a bit of a cluster next to it that does a lot of automated analysis. And those have very small steps in separate data analysis applications, written in R, by the way. And we really model them as, okay, we have a set of events that represent a file, then we split that by page, so then we have a stream of pages, and then we split that into sections of text, and then we split that into something else. And that just gives us, as an architectural level, the feel as if we're still writing functional code. And then you can just, in your architecture, literally substitute the name of a service by some sort of functional function which you use. Right, so it's a contract. Our intermediate models are contracts. And what we've learned is don't put them together in one repository because you want to evolve them separately. And if you do this, then building a new read model is simple. You just build a new microservice that projects a new model. And it makes it really easy to isolate this thing, so we no longer have to do this big bang deployments. Right, so conclusion, would we do it again? Yes, because we've solved the hard problems and we don't have to do that anymore, and we like Scala. Should you do it? Well, I think any piece of advice is not complete if you don't have at least some case where you should not do it. So there's a few questions that say, are you fluent in Scala? If you're not, well, why bother? Then just stick to the language you know. And one of the other things is, are you afraid of Axon's insights? And if you're afraid to dive into a framework and look at how it works and learn from that and try to map it to whatever platform you're using, try to stick to what the tutorials are telling you. But if you're not afraid of it, then go ahead. You might learn something, you might fix something along the way, because while we were digging through the configuration setup of Axon, we actually managed to submit a few pull requests to the Axon Framework where we found bugs. We wouldn't have found that if we just stuck to Java and the Spring Boot modules. So there's this way to enhance the project, enhance our own learning, and we really like it. So if you're saying, but I don't want it, that's fine. I hope something you can take away from here is that this functional architecture is not Scala specific. And if you've just been thinking, oh my God, that guy is simply rebranding serverless architecture. You're right, this maps perfectly to serverless architecture, but I just didn't want to call it the same thing because we're not using serverless architecture at the moment. But it could work just as fine. And we'll probably be migrating to that somewhere in the next couple of years. So I have one little Christmas list, things I'd like to see in the project. An even easier startup config. It's still a lot of things. We'd like a little bit of access to some of the components. Maybe that's a bit easier. I see Steven saying, "Oh, don't worry about it." So I hope there's good stuff on the way for that. And well, one of the things I said, well, maybe there's something to do about the Scala DSL to build aggregates, because actually there's one thing we really hate in Scala, and that's annotations. And you can't do Axon without annotations. So, well, yeah, maybe I'll be building this and then submitting it. But well, that's actually it. Thank you for listening. And if you have questions, I'll be here the rest of the day, and you can find me on the internet. And I'll probably have some pull requests coming up in the coming months. Any questions? Or, well, I'm also out of time, I think.